Okay, in this video we're going to look at the Pythagorean Theorem, and we'll have 4 examples. So Pythagorean Theorem is this. Here's example 1. Okay, here is example 2. Find the length of the hypotenuse. Example 3 is that. Wire from the top of a 20-foot pole. And example 4 is a ladder leaning against the top of a wall. Okay. So let's start with the Pythagorean Theorem. And if a triangle has a right angle, then C equals the square root of a squared plus b squared, where C is the length of this side of a right angle triangle. Now, a right angle triangle is a triangle with a perfect corner. Okay. This is 90 degrees, right? That's a perfect corner, a right angle, okay? It's like your floor up against your wall, okay? Perfect corner. Or the corner of your page, right? A right angle. Corner of your page is a right angle, isn't it? Okay? Okay, so C is the length of this side. B is the length of one of the sides, and A is the length of the other side. So basically, and C would be the longest side, wouldn't it? Or it's always the side opposite the right angle. So this long side is equal to the square root of this side squared plus this other side squared. Okay? So please write this down. Pythagorean Theorem. Write it down, and then we'll proceed. And press pause if you need some time to write it down. Okay? Okay, I'm going on to example 1 now, so please press pause, write it down. Okay, example 1. We've got, this is the length I'm looking for on this triangle, C, okay? And here this is 3 yards and this is 4 yards, and I have to find the length of C. So I'm going to use the Pythagorean Theorem, which says that C equals square root of a squared plus b squared. Okay, so let's use that then. If I want to find this unknown length, okay, I'll write C equals, so I mean, but the whole point is, like, this works for any shape of triangle. As long as it has a right angle, this formula works, but you just have to make sure the triangle has a right angle, and then the formula will work. So C equals the square root of a squared plus b squared. So one of the side lengths, say 4 squared, plus the other side length 3 squared. Okay? Does that make sense? So one of the sides is a and the other is b. So it's one of the sides squared plus the other side squared, and it's inside this big long square root. So I want you to write this out neatly like that. Okay, write it out completely just like that, nice and neatly. Take your time, okay? Now, in order to calculate this, we have to think about PEMDAS, really, the order of operations, because we don't actually have parentheses, but we do have a square root, which is kind of like a parentheses. It's just like, it's a grouping symbol. So we do parentheses, then we do exponents, and then we multiply or divide and add or subtract, right? Okay, but this symbol here is just like a parenthesis. So we need to do everything inside here before we take the root, is basically what I'm trying to say. And we can't add first inside here. We must do the exponents first, the squareds, right? So what's 4 squared? 4 times 4 is 16, right? What's 3 squared? 9. Okay, we're getting somewhere now. Now we need to add 16 and 9. What does that give you? 25. Okay, so now we have, C equals that, C equals that. So now we have C equals, what's the square root of 25? It is 5, right? And if these sides are measured in yards, surely this side has to be measured in yards as well. So it's 5 yards YD. Does that make sense? Okay. So one thing you can do is if you wanted to build a garden shed, and some people do this, and you wanted to make a perfect corner for your foundation of your garden shed, you could drive a stake into the ground, and then you could measure across 4 yards with twine or something. Okay, yeah, twine or rope. Okay, and then you could measure 3 yards in this direction. Okay, and then carefully, kind of, you know, don't drive. You would say drive this one in, but kind of move this one around until you manage to get your twine in this direction exactly 5 yards. So you've driven this stake into the ground, and you might say drive this one into the ground, and you just kind of move this one around so that this is definitely 3. This is exactly 3 yards. This is exactly 4 yards. This is exactly 5 yards. And if you achieve that, then this will be a perfect corner here for your foundation for the garden shed or whatever you're building. So anyway, that's just an application of the Pythagorean theorem, is that when you have one of the most famous right angle triangle is the 3, 4, 5 triangle, right? Because it has a perfect corner. Okay, let's go on to example 2. We've got this triangle, and it has a right angle like that, and it's 24 inches in this direction and 10 inches in that direction, and we want to figure out the length of C. And you know what, just for fun, go ahead and press pause and see if you can figure it out. Here's the Pythagorean theorem. Go ahead and plug in the numbers, see if you can get it. And it's a good thing to try, because if you make a mistake, then you can just watch the video and catch your mistake, right? Okay, so I hope you've pressed pause and at least tried it. I'm going to go through it now. C equals the square root of a squared plus b squared. Or one of the other side, you know, the long side C that is opposite the right angle, this length is equal to the square root of this length squared plus this length squared. So it'll be square root of 24 squared plus 10 squared. Okay, and just so you know, you could have written that if you wanted to. You could have written that root of 10 squared plus 24 squared. That doesn't matter. It'll work out the same in the end, right? Anyway, so we have C equals square root of. Now, we have to calculate the inside before we can actually calculate the root, right? And on the inside, we have an addition, but we have squareds. So what do you do first? Do you do exponents or do you add? Remember PEMDAS. What does PEMDAS say? Exponents first or add first? Order of operations says we must first do exponents and then we add, right? Add comes later. So 24 squared is 24 times 24. 4 4s is 16, carry the 1. 4 2s is 8 and 1 is 9. Put a placeholder 0. 2 4s is 8, 2 2s is 4, add, and we get 6, 17, and 5. So 5, 7, 6. Weird. Am I right there? 4 4 16, carry the 1. So 8. Yeah. So 5, 7, 6, and 10 squared is 100. Oh my goodness. So C equals the square root of 676. And yeah, sorry, that's a tough one to figure out. I'll just give you that. That's actually you could guess it might be 25 or 26 or 27. You might guess it's a little bit more than 24. And it's actually 26 times 26 gives that. See? 6 6s is 36, carry the 3. 2 6s is 12, and 3 is 15. Placeholder 0. 2 6s is 12, carry the 1. 2 twos is 4, 1 is 5. So 6, 7, 6, 7, 6. Okay, so this is actually, the square root of 676 is actually 26. Okay. Anyway, I don't think you have any that bad in the text, in the homework. Anyway, hope not. Okay, so that's the answer, and it's inches, right? Because if these sides are measured in inches, this has to be inches too, right? Okay, on to example 3. A wire from the top of a 20-foot pole is fastened to the ground by a stake that is 15 feet from the bottom of the pole. How long is the wire? What does that mean? Okay, let's draw a 20-foot pole. 20-foot pole. Okay? A wire is fastened to the ground by a stake that is 15 feet from the bottom of the pole. This is the bottom of the pole, and it means 15 feet horizontally. That's what it means. It means 15 feet over here in this direction. Okay? And then the wire comes straight down like that, making a triangle. So this is the wire, right? So the pole is this thing. This is the distance from the bottom, and the wire is this line here. Okay, and that goes from here to here. Okay, so we know the pole, this is 20 feet, this is 15 feet. The question is, what is this length here? We'll call that C. How about that? Because if the pole is straight up and down, well, it should be exactly straight up and down. Then you have a right angle, don't you? And this is the ground, right? Okay. So now we have a problem we can solve using the Pythagorean Theorem. If you have a right angle triangle, then the long side's length, C, is equal to, the long side is equal to square root of one side squared plus the other side squared, right? So we'll write down the formula. C equals the square root of a squared plus b squared. So C equals the square root of, and now plug in the other two numbers, right? So can you press pause and figure this one out? Try that. Press pause and figure it out. Okay, I'm going to do it slowly now. So we got 20, one side squared, plus the other side 15 squared, okay, which is the square root of, now 20 squared, I guess you could multiply that somewhere if you like. 20 times 20, 0 times 0 is 0, 0 times 0 is 0, put down a 0 placeholder. 2 times 0 is 0, 2 times 2 is 4, and we get 400. So that's 400. 15 squared, 15 times 15. 5 5s, 25, carry the 2, and 5 is 5, and 2 is 7. Put down placeholder 0, we get 5 and 1. So that's 5, and this is 2, carry the 1, that's 2, right? Plus 2, 2, 5. So C equals the square root of, and 400 plus 225, add those together, we get 5, 2, 6, right? 625, and now we have to get the square root of that. The square root of 625. Any idea what it is? Well, it's going to be more than 20. Okay, and so is it 21 times 21? If it was, well, 1 times 1 would be 1. 22 times 22, well, 2 times 2 is 4, so it can't be that. 23 times 23, well, 3 times 3 is 9, so, you know, that can't be that. 24 times 24, 4 times 4 is 16, so it can't be that. How about 25 times 25? 5 5's 25, carry the 2. Oh, that might work, because look, it ends in a 5. Carry the 2. 5 2's is 10, and 2 is 12. Put down a placeholder 0. 2 5s is 10 and carry the 1. 2 2s is 4 and 1 is 5. And that did work. 5, 2, 6. So the answer is, well, what times itself gives 625? The answer is 25. And of course these are all measured in feet, right? So 25 feet is the answer. That's the length of the wire, 25 feet, right? So this one won't be too difficult to figure out with the numbers. Please press pause in the video, do this entire problem yourself, and then check it, okay? So please press pause, do the whole thing, and then check to see how you did. Alright? A ladder is leaning against the top of an 8-foot wall. If the bottom of the ladder is 6 feet from the wall, how long is the ladder? Okay? So did you get stuck? Hopefully you've got stuck and you've tried with this. So here's the wall, I guess. Okay? And the ladder is leaning, the wall is 8 foot high, isn't it? Okay. Ladder leaning against it, and it's 6 feet from the wall. The bottom of the ladder is 6 feet from the wall. So the wall is 8 foot high. The bottom of the ladder is 6 feet from the wall, and so that means the ladder is going like that, right? That's the wall. This is 6 feet from the bottom of the wall. And how long is the ladder? Well, do we have a right angle triangle? We do. And the right angle is where? Where's the right angle in that triangle? Jingle jangle. Right here, isn't it? The right angle is right there. Okay. So this we'll call C just for fun. Okay. We'll just use C for the length of the long side of the triangle, right angle triangle. And with the formula, we have C equals the square root of A squared plus B squared. So write the formula out. You remember 40% of what you write down. So you know, if you just keep writing things down, it'll sink in. That's one of the reasons we do lots of homework for repetition, so it kind of sinks into your brain, and you remember it during the next class and things like that. Okay, so A squared is you could say 6 squared, and then plus another side length 8 squared, right? So we have C equals square root of, and you know, if you were continuing from here, please press pause at this point and finish it off. Please press pause and finish the question from here, right? 6 squared is, now I'll do it. 6 squared is 36. 8 squared is 64. And I hope you guys can add those together. 4 and 6 is 10. Carry the 1. And that's 100, right? And the square root of 100 is, what times itself gives 100? 10. And that's the answer. The length of the ladder is how long? 10 watts, 10 inches, 10 yards, 10 feet. Okay.